Yeah. Good evening, everyone. So, joining camps, let's start off. Sure. Others comes on. This was the last thing that we were doing, the horizontal one. Next thing. Motion in a vertical line. So in the last class, we dealt with when the things were going left and right. Motion in a vertical line. So every body on the surface of the earth is attracted by the earth, generating an acceleration so this acceleration due to gravity we represent with small g. This value is around 9.81 meter per second square. But for convenience, we take g is equal to 10. So in our problems, at least when nothing is mentioned, you can take g10. But even in the exam, right, they will give you g value. If they don't give you also, you can look at the options and figure it out. Instead of 20, they'll give 19.6. Instead of 10, they'll give 9.8. So that is the biggest hint there that they took g as 9.8. And now one thing, if you observe here, this is independent of mass. Means you take an elephant, you take a coin, you take a feather, it doesn't matter. The acceleration due to gravity is independent of mass in vacuum. That is the thing. In real life, what happens because of air resistance, right? Things don't behave the way we study theoretically. If you drop a feather and if you drop a coin, we know definitely the coin is going to fall faster. That's because of air resistance. But if you remove the air, you'll observe they all actually fall with the same acceleration. The same thing, if you take something like G on the moon, this is almost 1/6 of the Earth's gravity. So if you take G on the Jupiter, that's around 62.1 meter per second square. And no need to remove the values, just giving you. That means if you see on Jupiter, the gravity is almost 6 times more than Earth. Have a look at this. Who is missing today? Great. Next thing. Now, the important thing, when we keep saying, gravity is attracting up and down, what is up and down? What do you mean by up and what do you mean by down? Anyone? This is up, this is down, something like that. What do you mean by up and down?
Against gravity, towards gravity.
So, if you just say up is this and down is this, the problem with that statement is, do you mean to say people in the North Pole are standing like this and people in the South Pole are walking with the head? and people on the equator are crawling on the floor. You're getting it. So what do you mean by up and down exactly? Like what we just said. Even gravity is fine. That's a decent thing. This is how people are standing there. So at least for the Earth case, when you say up and down, down is nothing but toward the center of the Earth. This is down. This is down. This is down. What is up? Up is away from the center of the Earth. So a better definition would be, this is quite a useful thing. We are going to encounter this up and down concept a lot later on. So when someone asks you technically what is down, down is the direction of the net force. The direction of net force is taken as down. So that means when you go into a gravity-free space, right, in a satellite, where you feel like there is a gravity-free space, tell me one thing. When you plant a tree on that, how does it grow? It grows up. Now, if you plant a tree in a gravity-free space, how should it grow? How do you think a tree will grow in a gravity-free space? So technically speaking, the actual thing is that trees just don't grow up. They grow towards the sunlight. So in a gravity-free space, if there's a light everywhere, the tree will grow like this in all directions, like an afro. Getting it? The center part will be the root system and the leaves are just expanding outward. But let's say if there's a light here, then the trees would grow more on this direction. So in a gravity-free space, the trees grow towards wherever there's a light, they'll grow that side. So if you're giving light in all directions equally, then the tree will just grow like an afro. The center part will be the root system and it goes in every direction. Getting it? So gravity-free space has a lot of problems. We humans cannot survive. If we go into the space, we lose a lot of things. First thing, your arteries and veins in your legs are thinner compared to your arteries and veins in the upper part of the body. If you ever played with a water tap, you must have realized this. If you have a tap like this, if you close your finger half of it, what will happen? Speed increases, right? If you close a part of the water tap, you will observe the water goes out much faster. So when a person is standing, the blood from the legs has to reach the heart. That means they need more speed. Getting it? They need more speed. That's why the arteries and this thing are thinner in the lower part of the body, the legs, so that the blood can be pumped till the heart against the gravity. Now, when you take this person into a gravity-free space, what is the problem? The blood is still being pumped faster. The blood will start accumulating in the head. You're getting it? And the brain will start thinking, oh shit, I'm producing a lot of blood. And it stops producing RBC. And you become anemic. You're getting it? We human bodies are not designed to stay in gravity-free space for a long time. You start losing muscle mass. If you see, even though you don't exercise every day when you're standing and sitting, you're pulling your whole body weight against gravity. So there is some muscle. Once you go into a gravity-free space, there is no need for you to use muscles. So muscles will start degrading because they consume a lot of energy to maintain. Anyone has seen the movie Wall-E? There's a small robot which cleans the trash on the earth. There's a animated movie like this, Wall-E. There's a movie like that. If you're not seen, fine. In that movie, right, all the humans leave the earth because earth is polluted and they live in a spaceship outside the earth. And they send robots to the earth, telling them to clean the earth. And when it is clean, they'll come back. Aisa kuch to tha. So these people, right, they forget they have to come back to earth and they just chill out in the spaceship, all humans. And these humans living in the gravity space for a long time, for years, generation after generation, normally a human would look like this. These people, right, they become fat like this. There is no muscle, nothing. You're just fat, a big bulge of fat. You should see that movie. They'll clearly show like how humans have evolved during the time. There's the scene in that the robot sees the people. No one can walk on their own. They're being transported on trucks left and right on a small carts. It's pretty weird. That's what happens to humans if you put them in space. So these astronauts who go into space now, every day they do 4 hours exercise just to maintain a normal body weight. Just to be like you and me normal on the earth, they have to do 4 hours exercise. And when they come back to the earth, if you see, right, most of them can't walk for a few weeks. They have to be dragged out of the spaceship. Their legs can't sustain the gravity. So yeah, gravity. So if you are ever, humans are going to the space, we need to find a way to create this gravity. Somehow we need to do something about the gravity, or else we can't live in space. Anyway, so that is one part. Now, when we study this thing, we will work under some assumptions. So whatever motion we are studying, we study under certain assumptions. The first one, we neglect any air resistance. So if there's an air resistance, things go pretty weird. It becomes very complex to study. Second thing, we neglect any variation in gravity. This is still acceptable. Generally, gravity on the Earth's surface up to 7, 8 kilometers doesn't change. But once you go more like 50, 100 kilometers, it changes appreciably. We neglect any variation in gravity. So G ka value, we treat it as almost constant on the surface. Third, we neglect the Earth ka rotation. Now, when you throw just a coin like 10 meter, 20 meter, kuch problem nahi hoga. But if you're launching a missile and you have to launching it 200, 300 kilometers, by the time the missile reaches there, the Earth would have rotated. So if instead of hitting, your Ghatkopar station, it will go and hit Kolaba. So that is what would happen. You'll get a huge errors. We neglect Earth's rotation and we also neglect Earth ka curvature. Earth is not flat. Basically, we treat Earth as flat. That's the reason when you're building a tunnel, 1, 2 kilometers, it's a very difficult building a tunnel, for like 7, 8 kilometers. Just imagine, let's say Earth is there and you want to build a tunnel between two cities here. So if you go here and build a tunnel, this is what will happen if you go straight. You'll come out of the Earth somewhere. So you have to build a tunnel like this. You have to curve with the Earth. Itna kyun? Imagine you build a very big building. You know how it looks? If you build a very big building with a flat base, isn't this how it looks? Like a seesaw? So just imagine, the India ka parliament or maybe this Pentagon in US or any big building. They're not flat at the bottom. So the building should be like this. You're getting it? The bottom part is not actually flat, it is curved. Now, if you're just building a small building, it looks flat. But if the building is pretty large, let's say something like this width is 2 to 3 kilometers long, such long buildings, they're not flat anymore. Getting it? So while building tunnels and all, there's a lot of things. So Earth ka curvature does matter a lot. And Earth ka rotation matters a lot. I think just to give a simple example, did you ever observe this thing? If you take India, right, we get a lot of cyclones in Bay of Bengal. If you see now, my hometown is Vishakhapatnam, the east coast. Mumbai is somewhere here. For us, now there is no monsoon ka concept. For us, all the drinking water we get is from storms. Every 2, 3 months we have a storm. It comes for 4, 5 days, we get water and we are happy. Matlab, it's a common thing. You will see this in the news also. Next time, observe this. There's a cyclone in Bay of Bengal which is going towards Tamil Nadu. There's a cyclone going towards Orissa, cyclone towards Andhra, cyclone towards, meaning it, the cyclones are just coming and going. But rarely you will hear there's a cyclone in Mumbai. There's a cyclone in Arabian Sea. Ever thought about it? If you go to US, right, you'll always observe that tornadoes and the storms, everything, they hit the east coast, the Florida part. You will never find cyclones and storms on the west coast. Reason, the Earth is rotating from west to east. So when a cyclone forms in Bay of Bengal, the cyclone is there only. Cyclone is not coming towards you. Earth is going towards the cyclone. So any cyclone that forms in Arabian Sea doesn't come to India. It goes to Dubai. You're getting it? In a pretty very rare phenomena, the cyclone it does come towards Mumbai, but it gets dragged away again. That's because of Earth rotation. In geography, you learn this thing as Coriolis force, if you remember it now. So Earth ka rotation does matter. Earth ka curvature matters a lot. During World War II, as these people were designing, better and better warships, they started making more and more powerful guns. Now the problem is the guns have become so powerful, you are sending them 40, 50 kilometers. Now, if there is a ship here and if you have a ship here, this ship can't see the other ship, isn't it? You can't see the other ship because the Earth is curving. And if you look at the Earth ka curvature, right, approximately for every 8 kilometers, if you go straight 8 kilometers, the Earth goes down by 5 meters. That is the curvature. Means if you can walk in a straight line for 8 kilometers and then you look down, you'll be 5 meters above the ground. So Earth actually curves like this. So what these people used to do now during the World War II? So you have a ship here, you can't see. You have a ship here, you can't see. But your shells or these bullets can reach here because they go in parabola paths. They'll curve because of gravity. So these people used to launch an aeroplane, like a small scout. This aeroplane used to see the ship, and this aeroplane used to send the signal to the mothership, which is below, telling where is the enemy ship. These people used to adjust the angle and used to fire. So you can't see the enemy ship. You don't know where is the other ship, but you're firing already. And these Shipka people, right, suddenly used to get hit right and left, and they never used to understand where they're coming from. And then they realized, okay, they're using these aeroplanes like this. So these people used to use their own aeroplanes. So they used to fight with each other without seeing each other. Then someone thought, why don't we send these planes only to fight? This is what we built, aircraft carriers. So that is how airplanes became very prominent. The reason why we have so many planes and airlines all because someone thought it's a very good idea to take a plane, put a bomb and throw on the enemy side. People thought it was a stupid idea to put people in a plane and transport them. But when it came to a bomb, people are quite excited. That is how technology grows. Every time there is actually a war, humans advance in technology rapidly. Rapidly, matlab, you can't even imagine. Every technology today that you are using, 90% of it were discovered or the principles, foundations were laid in World War II. Your computers were actually designed during World War II in order to break the German code Enigma. That was the first computer. Your CDs, your disks, wireless communication, everything you're talking today that we are using, all the foundation was laid in World War II. Because whenever there's a war, you get a hell lot of funding to do any nonsense. People don't ask why. They say, chalo, take the money and get a better weapon. So, whenever there's a war, humans advance in technology. And once the war gets over, we are busy playing with Instagram and doing all nonsense shit. Think about it. You're hiring the world's best engineers, world's best tech guys, and you're hiring them in Instagram, Snapchat, Facebook, Twitter, and Uber. And what are you making them do? Instagram mein put a filter. When you take a photo, you should get a dog ka ears. When you take a photo, you should be smiling like this. And that is what you're doing. You take the best of the minds in the world and you're making them do all nonsense. Because it's a peacetime, people are chilling out. And people get paid to do all that shit. So what will they do? They will do the same thing. So there is no innovation as such. Best example, look at your mobile phone. Going from a Nokia mobile to a smartphone is an innovation. Agreed? That's an innovation. That's a leap, right? Taking a smartphone and putting a camera, right? That was an innovation. Then taking a smartphone, putting three cameras is not an innovation. That is bullshit. Right? And putting three cameras in the front, putting one camera in the front, removing the head jack and everything, and just putting a good battery doing all shit, and that is not innovation. That is something else. And putting a 12 GB RAM, what the hell are you trying to do? Building a nuclear missile or a supercomputer? So yeah, that's the difference. Anyways, so the Earth, right, curves for every 5 meters there. Itna kyun? The Earth curvature actually, if you see now, because of the Earth curvature, humanity survived the Cold War. During the 1950s and 60s, right, US and Russia have gone mad and both started building nuclear bombs. They started making more powerful nuclear bombs. The most powerful nuclear bomb Russians made was the Tsar bomb, TSAR. This bomb is 2 lakh times more powerful than the Hiroshima Nagasaki bomb. 2 lakh times. Meaning, in front of the Tsar bomb, the Hiroshima bomb looks like a small, I don't know what is that. Diwali mein hota hai na small cracker aisa hai. So they have gone mad. They're making more and more powerful bombs. At one point, both Russia, USSR that time, and America, they realized there's no point in making bombs, and they stopped making. They just stopped. You know why? Not because they realized, the peace is more important, or they realized that humanity is great or something. Nothing like that bullshit. Earth ka curvature has stopped them from making big bombs. Because look at this thing. You make a bomb so powerful, it can blast up to 200 kilometers. Means if you put a bomb in Mumbai, you can blast off Pune also. You made a very powerful bomb. But the issue is, the moment the bomb explodes, the radiation and the shock wave will travel in straight lines. Isn't it? Now Mumbai is here, Pune is here, 120 kilometers, so the blast will go above Pune city. Pune is safe. You're getting it? So making a powerful bomb is of no use because all that energy and radiation will, spread into the outer space. The cities won't get affected. So making a powerful bomb is not a good idea. It doesn't work. Then, as usual, we humans are always innovative. So we started designing something called multiple entry vehicle launch. So we launch a missile, it goes into the space. Then it has 7 missiles. It opens up. It launches 7 independent missiles on 7 different cities. There. We'll always find a way to destroy more. By the end of the Cold War, this US and Russia, they made so many bombs, they can destroy the entire Earth 24 times. They had so many nuclear bombs. You can destroy the entire planet 24 times, one after another, one after another, one after another. They have gone that mad. So, yeah, welcome to life. And nowadays, so no one gives a damn about anyone. People are just busy with Instagrams, PUBGs, and all. So let's see something this gravity ka stuff. So next time when you think about Earth's curvature, tank it because people stopped making more powerful nuclear bombs. I think the most powerful one we have is 20 megatons. Let me show you something. This I think I showed you this in the foundation. But let's see that again.
This is NASA's Space Power Facility near Cleveland, Ohio, and it is the world's biggest vacuum chamber. It's used to test spacecraft in the conditions of outer space, and it does that by pumping out 30 tons of air in this chamber until there are about 2 grams left. And it's kind of got an
This is actually a nuclear missile launching site. After the Cold War got over, NASA took it over and they converted this into a vacuum facility. So whenever they want to send a spaceship before, you have to test it, right? Whether there are any leaks or any problem in vacuum. So they put that spaceship inside this, they remove the air, and then they test for the integrity. How does it work and all.
Construction, which is part of its outer concrete skin, which is part like radiation shielding and parts an external pressure vessel. So this thing can take force that's present on the outside when it's pumped.
There.
Galileo's
experiment. So they took a bowling ball, they took some feathers, and they just dropped it. So there's an air there, expected. The ball falls down, the feathers come down, aram se. This is what we see on daily basis, air
So in
resistance.
this case, the feathers fell to the ground at a slower rate than the bowling ball because of air resistance. So in order to see the true nature of gravity, we have to remove the air.
Now, if you remove the air, looks nice, huh? The big door and all. Quite a thick door, right? So he says almost it takes 4 hours to remove all the air, 3 to 4 hours.
PCB 30
So they removed all the air inside. Now they're dropping.
5, 4, cameras on, 2, 1, release.
They left it. Observe them, they're always side by side. Exactly same thing. See, there's no fluttering because there's no air resistance, nothing. There, they land at the same time.
Exactly. Exactly. They came down exactly the same.
Theoretically, everyone knows that they land at the same time. Seeing is something else.
Exactly.
You're back on the side.
Exactly.
There.
the same.
So we're not bluffing. It does fall at the same time. Yeah, Daksha, Borana, you was asking something.
So basically, if we talk about upward or downward direction, can we also say that if you have a reference point and if there's an object above it, then we can say the object is in the upward direction. And if it's below the reference point, then it's in the downward direction.
Now, see, you want to say that you can say, but then again, normally, how do we define down, right? You take an object and leave it. Whichever direction it falls, that is down. When you say up and down, it is always with respect to you, isn't it? We humans, we see with respect to ourselves. So if the force is this way, and if I drop you, you also will be standing in this way, isn't it? So what you think is up and down, but you want to define a new thing, that is fine. You can define. Generally, when we say up and down, it is with respect to humans. Okay?
Okay.
Great. Now, going back to this, so let's get back to the calculation part. So if you consider a particle, I'll send that video in the group. You guys can watch it more aram se. So if you project a particle with speed u vertically, now technically, right, if I throw like this, it will go up and come back on the same line, but it will be difficult for us to understand. So I'll be putting it little to the side. Okay? Whereas in reality, it is actually going on the same line and coming back on the same line. So at the highest point, velocity is 0. This is called h max. This we will define as ay, which is g, the subscript. So h max is the maximum height from the point of projection. Then we will define something called u subscript y. So the subscript y indicates the direction. So this is initial vertical velocity. If I say ux means initial horizontal velocity. A subscript y is your acceleration in vertical direction. Now, at the maximum height, the velocity becomes 0 for a moment. Obviously, think about it. If the velocity is not 0, why will it stop? It will continue to go ahead. That means that is not maximum height. The vertical component of velocity is 0. So using the equation v square minus u square is 2a, as the three equations are still valid. So highest point velocity is 0. This is u square, this is 2 minus g. Be careful, up is positive, down is negative. So if the gravity is pointing down, it is minus g. So we get h max is equal to u square by 2g. But a better way to remember, I would prefer this: uy square by 2 times the magnitude of ay. Same thing, but we are just writing in terms of y everything. And be careful, this formula is valid only if ay is constant. If acceleration is changing, you can't use this. So vertical velocity square by 2 times the acceleration in the vertical direction. This is a more general formula, because every time there is no guarantee the gravity will be g only. It can be more, it can be less, it can be anything. There, have a look at this. Don't worry, in the end I'll write a summary of all these points, then you can note down that part. But have a look at this page. Ask me if there's any confusion. Clear? Turn in the page. The time of ascent. This is the time taken to reach h max. Again, we are using the equation v is equal to u plus at. Highest point may be 0. This is u minus g and time of ascent. So we get time of ascent is u by g. Again, the more general formula will be uy by ay. And then we have time of flight. The symbol is TF. This is the time taken to reach the ground. Now, when you throw it from a ground level, you go up and you come back to the same level. If you come back to the same level, the displacement is 0. So using the equation S is equal to ut plus half at square. This is u time of flight minus half g time of flight square. We end up with time of flight is 2u by g. A better formula would be 2uy by ay. But remember, there's a restriction on this formula. You can use this only if you come back to the same level. What do you mean by that? For example, if you start throwing from buildings, if you throw from a building like this, you go up and you come down. You're not coming to the same level. Or if you throw from a building like down, so not valid here. For this, we have to use in a different way. We will see that later on. So this formula is valid only if you throw and you come back to the same level. So keep that in mind. So don't blindly use this formula 2u by g everywhere without understanding. It is good to remember formulas, but you should know when to use and when not to use. Have a look at this. Clear? Any doubts on this page? Next one. Time of descent. is the time taken from H max to ground. If we know the time of flight is time of ascent plus time of descent. So from here we get time of descent is equal to u by g. Again, this is not valid for buildings. There, have a look at this. So let me just summarize all the things once more. Any doubt so far? Please ask me. Let's. So you projected a particle with uy. You go up and then you come down. This is your acceleration ay. So let's say somewhere here your velocity is vy. And this is your height from the ground y. So your equation vy is equal to uy plus ay. Basically v is equal to u plus at, put everywhere y by y. So this becomes vy is equal to u minus gt. So the subscript y indicates you're talking in vertical direction. The second equation becomes sy uyt plus half ayt square. This becomes the height y is equal to ut minus half gt square. This y here is the height from the ground level. The third equation is vy square minus uy square is 2ay sy. This becomes vy square is equal to u square minus 2gy. There, this is what happens to your three equations. We are just writing the subscript y everywhere. And then your other formulas are time of flight is 2u by h max is u square by 2g. Time of ascent is u by g. Time of flight is 2u by g. Time of descent is u by g. Be careful, these are not valid if you throw from buildings. If you throw from buildings or if you throw from certain height, you don't use them. Now, sometimes what happens, acceleration is not constant. We'll be doing these kind of problems also in the next class. If ay is not constant, then you don't have an option. You have to go back to the old base old integration. So vy will be dy by dt. And acceleration ay will be dvy by dt or vy dvy by dy. V dv by dx. You're just adding subscript y everywhere just to show it is in a vertical direction. There, these are the main formulas. You can note down them if you want. That's it. This is the
So
theory.
this is not constant, right? The integration.
Sorry, ay is not constant.
And so I have one more doubt.
Hmm.
In the previous one, the acceleration is constant. Over there, on the same page, the time of descent and the time of ascent is the same, right? U by g.
Right.
But if we logically think, when you are like throwing a ball up, it's working against gravity, and when we are throwing it down, it is working towards gravity. So won't gravity help? Oh,
When you neglect air resistance. When you're going up, who is stopping you? Gravity. When you're coming back, who is helping you? Gravity. That just gives back you whatever you gave. If there is no air resistance. If there's an air resistance, the whole game changes. You can note it down. Those who want, put it off. You can put down the main things. Anyway, you'll get. So because last class someone was asking, sir, should I make a separate formula sheet? Should I make a separate notes? This is what I'm telling you again. You're not in school. Making beautiful notes, writing down formulas, all that will look fancy and it will feel like you're doing some very good work. But that is all bullshit, and that is just, all on the surface level. You really want to do good work, solve more questions. You're getting it? If someone is saying, sir, I'm doing a really good work, that means you solve at least 30 questions per subject for all 3 subjects every day. That's a good work. Sitting for 2 hours and making a beautiful notes is bullshit. That is just to satisfy your ego, saying like, देखो मैंने 2 घंटा पढ़ाई किया. And making a beautiful notes is one of your school ka habit. No one gives a damn about it. Do you really think tomorrow when you go to IIT, right, you'll be valued because you're writing your notes beautifully? Or will you be valued contributing to the project and working on the project and thinking about it? Tomorrow, itna kyun hai? When you tomorrow write your PhD ka thesis, will you be writing with your hand or you will be typing it on a computer? You'll be typing it on a computer. So where is your great, beautiful handwriting that you did? So let's be very practical about it. No one gives a damn about your handwriting, right? So don't worry about the notes. I know my handwriting is not great, but it is understandable. Anyway, after 2 years, you're going to throw the notes. So try to absorb from the notes as much as you can. Meaning, chalo, fir bhi tell me one thing. We did 71 pages. We did almost 18 questions. How many concepts did I use till now here? What formula sheet will you make? You will make this formula, distance. Now you tell me, by writing down this formula, will it really help you? Whenever you see this formula, do you remember anything? Nothing you'll remember, nonsense. But after seeing this, if you solve this problem, now it makes more sense, isn't it? If you see this problem, it would make more sense. Just reading that formula will do nothing for you. So whenever you want to revise something, revise the full notes or solve more problems. But if someone says, no, sir, writing a notes, I learn better. Yeah, please be my guest. Do it. After 3-4 months, you won't have enough time to do everything. So focus more on solving questions. Next thing. Let's see a question, all copied. So don't worry about writing beautiful notes and all. That is all nonsense. Focus on more solving. People do all those kind of things, because sitting and solving and thinking is more difficult. You can sit and write the notes for 1 hour. It looks nice. And it gives you a false feeling like, you studied for 1 hour. That's what I keep telling you. The amount of time you studied is proportional to the number of questions you solved. If you're sitting and reading notes, that is not counted as studying. If you're sitting and watching videos, that is not counted as studying. The earlier you accept this fact and the earlier you realize this, the better, faster you'll improve. Next thing. Let's see a question. Till now, I did 18 questions. Did any question repeat? Then, and every question is something new. Let's say you projected a particle with 20 meters per second. Gravity G is 10 meter per second square. So this guy goes up and comes down. Find the first thing, H max, time of flight, time of ascent. The second thing, time and speed when it reaches H max by 2. Speed and height. At 1/4 of the time of flight. Distance traveled. In 3/4 of time of flight. There. Let's get them out. Just formula based. There is nothing too much to think. In this entire thing, if there is some good question, this D is a little decent one. That ABC are nonsense. But yeah, you'll get a formula based. Let's get them. Let's see. Yeah, no, we got it wrong. Give me the answer for BCD. A ka answer and everyone knows. Got an answer, type in the chat box. Especially D is the answer I'm looking at. Abhinav, God, what are you doing exactly? B speed is 0. It's not 0, right? Look at the first one, Hmax. U square by 2G. U is 20 square. This is 2 into 10, so that's 20 meters. Time of flight is 2U by G. That is 4 seconds. Time of ascent is U by G. That is 2 seconds. Straightforward formula substitution. What about B? 10 root 2 and 2 minus root 2. You will get 2 roots of time, right, Shana? Both the roots are acceptable. Why did you ignore the second root?
Sir, I thought it was for ascent only, so I took the smaller time.
No, I simply said Hmax by 2. Both you have to give. If it is a more than one just question, you have to mark both of them. So for the B part, you're asking, find the speed and time when it reaches Hmax by 2. So look at the data there. So displacement is Hmax by 2. And that is a 10 meter. So you are using the equation S is equal to ut plus half at square. So S is 10, U is 20, gravity is 10, and that's t square. You get a quadratic equation. We end up with t square minus 4t plus 2 is equal to 0. When you solve this, you end up with 4 plus or minus b square 16 minus 8 by 2. This turns out to be 2 plus or minus root 2. This we talked about it in quadratic equations in basic maths. So the thing is, the total height is 20 meters. But you asked me, find the time when it reaches half of the height, and that happens at 2 times. Once while going up, that will be the smaller time because you go up first. The second one will be 2 plus root 2 while coming down. So there are 2 times when this thing reaches the 10 meters. And the second thing you asked is for the speed. Speed is straightforward. V is equal to u plus at. This is 20 minus g is 10, and height, sorry. V square minus u square is 2as. V square minus 20 square, 2, a is minus 10, and g is 10. You end up with v is equal to 10 root 2. Please check. Ahana, that is wrong. Pratik, that is wrong. Please check the B part. If you got it, go for the C part and D part. Keep going. Any doubts on B part, please ask me. It is just formula substitution. There's nothing there to think. But anyone still confused, please ask. Don't hesitate. Get it clear. You're clear, please go ahead with C and D. Right, Ishana, you got that. Nay, Ansh, that's wrong. Some of you are not typing answers. Either you're not trying or you don't give a damn about this. Or maybe you're shy. Don't feel shy. Do type. Nay, Arya, that is Sika. Speed and height, okay. Devansh, you're right. I'm mostly interested in Dika answer. Purvaja, you're right. Vihan, you're right. Yeah, most of you are getting Dika answer. Look at C. Find the speed and height at 1/4 of the time of light. So time is TF by 4. That is 1 second. Speed will be V is equal to U plus AT. That is 20 minus 10 into 1. So that's 10 meters per second. And the distance will be UT plus half AT square. That will be 20 into 1 plus half into minus 10 into 1 square. That's 15 meters. Now look at the D part. Find the distance traveled. That is the first word. It is not a displacement. Be very clear. I told you this n number of times. You hear the word distance, have some fear. If you don't learn these things, I'm telling you, when you see some words, that is like some clues and hints. And if you don't get used to, remembering these hints and clues, you'll be slow in the exam. The moment you see the word distance, your brain should get alert, boss, something is going to go wrong. So you need to develop an instinct like this. That happens when you solve a lot of problems. And I'm actually helping you to suggest you a few things like that. So distance is asking. So if I use this formula directly, so the time is 3/4 of time of flight. This comes out to be 3 seconds. So if I use my formula, UT plus half AT square, this is 20 into 3 plus half G is minus 10 in 3 square. This turns out to be 15 meters. But remember, this is displacement. So that means when you projected this, now understand the whole thing, height is 20 meters, isn't it? That is your H max. At the maximum height, time of ascent is 2 seconds, meaning 2 seconds you're at the topmost point, 3 seconds you have already started coming down. So 3 seconds you are somewhere here. That is how I know which side you are. And you got displacement. Displacement is initial distance between initial and final point. So I don't care how much you have traveled. Displacement is simply initial to final. So what is distance? This green line is your distance. Isn't it? You have gone up and you have come down. So how much did you go up? 20 meters. How much did you come down? 5 meters. So what's the distance? 25 meters. I hope everyone is clear with that. So I told you this multiple times. If it is distance, you have to draw the diagram. Without the diagram, you won't understand what is happening. The particle is going up because 2 seconds you're already at h max. 3 seconds you started coming down, means you went up and you're coming down. And if you use the formula ut plus half at square, that will give you only this distance. It won't tell you how much you have gone up. So you have to draw the path and check it out. Do have a look at this. This would be a good mains level question, the D part. Any doubts on this? Anyone not convinced with this? Any confusion? Please ask. Let's see. Next one. Can I go ahead? Any doubts? Let's see something better. So we have a particle projected with speed u. It goes up, comes down, hits the ground. The speed becomes u by 2. Then it goes up, comes back, hits the ground. The speed becomes u by 4. And it just goes on. So every time it hits the ground, the speed becomes half. Like I said, the diagram actually happens on the same line. But if I draw like this, you won't understand anything. So it will be like this. Then the third line would be like this. So they're all, it's like this. They're just a particle is projected vertically with speed u. After colliding with the ground, its speed becomes half. Find the total distance, total time, and average speed. Around speed becomes half. Find total distance, total time, and average speed. Let's get this. Now for people, in case you forgot, I hope you remember this sum of infinite GP. A r power 1, a r square, so on till infinity. This is given by a by 1 minus r. This is for r less than 1. I hope everyone remembers this, so I'll not be showing you more. That is sum of infinite GP, where a is the first term and r is the multiplying factor. I hope everyone knows this. Anyone who doesn't know this? Yep, most of you know this. Great. Let's go. Just give it a try. I'll get some water and come. How do we do this? Any answers for total distance, total time, average speed? Distance is 4u square by g. Yeah, that's right, Reshana. You have right. Vihan, you're wrong. Jainil, that's wrong. Surya, that's wrong. How did you get time record? Time is not given. Nee, Ahana, that is wrong. Others should type your answers. Adi, Vignajit, answers. Pratik, Arya, Ojas, Vishank, answers. Nikhil, you got it. Vignajit, you're close by. Right, Ishana, you got it. Time 5 plus u. What is u? What is 5? How did you get 5? H is minus u square. Why the hell did you find h, Ray God? What is h?
Oh, sorry, I meant to say total distance.
Minus sign. Total distance is minus. Let's see. Some of you did get the answer. The first thing, when you project with speed u, you go up, then you come down. So this is your h max. Now see here. What is h max? H max is u square by 2g. This is proportional to u square, meaning if the speed becomes half, distance becomes 1/4, isn't it? It's a square function. So the second time, when the speed becomes u by 2, you go up and come down, but the distance is only h by 4. The third time, when your speed becomes u by 4, now your distance becomes h by 16. Is that making sense? So it's just u square function. So your distance every time becomes 1/4. So the total distance will be, now this is a mistake one of you did. It is a distance. So you're going up and coming down. So 2h na, you have to count while going up, you have to count while coming down. So distance. So 2h, 2 times h by 4 plus 2 times h by 16 and so on till infinity. So if you remove 2h common, you will observe you get a sequence 1, 1 by 4, 1 by 4 square, so on till infinity. We can use the infinite GP, you end up with 2h is 1 by 1 minus 1 by 4. That turns out to be 8h by 3. But we know h is nothing but u square by 2g. That answer is 4u square by 3g. That's your total distance. Similarly, if you look at the time of light, time of light is 2u by g. That is proportional to u. Means if the time is t here, then the time is t by 2, then the time is t by 4 and so on. Then the total time will be t plus t by 2 plus t by 4 and so on till infinity. So if you take out t common, you will get 1 plus 1 by 2 plus 1 by 2 square, so on till infinity. This gives out a sequence 1 by 1 minus half. That turns out to be 2t, which is 4u by g. What's average speed? Total distance by time. The total distance is 4u square by 3g. The time is 4u by g. You end up with u by 3. Please check your calculations. There, infinite GP and the time. So the height becomes every time 1/4, 1 by 4 square, 1 by 4 cube, whereas the time becomes 1, 1 by 2, 1 by 2 square, and so on. So height goes as a 1 by 4 function. time goes as a 1/2 function. Check this out. Any doubts? Anyone not clear? Please see where you goofed up the steps. Vignesh, got your mistake. You forgot a 2 there. But I think rest you got it. Others, how did you get time ka thing in this thing? I didn't understand. So please check it out. See where you messed up. All clear? Next one. Any doubts? Ansh, got your mistake? Ahana, got it? Okay. But Surya, did you get the same answer? Then it is wrong, na record. If you're not matching the answer and if you did some other method, means you are wrong. Next thing. Okay, started enough. Let's see next one. Let's do even better. Now, how can they frame a question? Advanced. This would be mains mate is a tough question. Advanced mate is an easy one. So we have a weird planet here. So for every 10 meters, the gravity becomes half. So first 10 meters gravity is g. Second 10 meters gravity is g/2. Next 10 meters gravity is g/4. Next 10 meters gravity is g/8 and so on till infinity. For every 10 meters, the gravity becomes half. And you're projecting with speed u from the ground level. The gravity becomes half for every 10 meters. You can take g as 10 meter per second square. So the first question, if someone is projecting with 15 meters per second, find h max. Remember, the h max formula was derived under the assumption the gravity was constant. Second one, this would be a good one. So this would be mostly a paragraph type question. Find the minimum speed. So if you throw with a certain minimum speed so that it never comes back, you should go to infinity. This is also called as an escape velocity. More about this we will talk in gravitation. But for now, you have an idea. So what is the minimum speed you should throw so that this never comes back? I hope the question is clear, everyone. You've got a planet whose gravity becomes half for every 10 meters. Try this. So if this was a paragraph question, I'll ask you like this 2 questions. Generally in a paragraph, one question would be easy. The second one will be slightly tougher. Try. You got 2 minutes for the first one. Anyone got the H max? Purvaja. See, you did a mistake there. How did you get so small value? See now, forget about everything. If I just use the formula u square by 2g, right? How much will you get? 15 square by 20. That is 225 by 20. That is 11.25. So this is definitely wrong, right? Should be definitely wrong.
Sir, I didn't use the formula. I got it by something
Yeah,
else.
that means you goofed up that.
Yes,
That
sir.
means you goofed up that, na? Ha, dekho. Ah, Jainil, you got it. We have one answer so far. Jainil got it. Purvaja. No, that is gone anyway. Arya, you're gone. Daksha, you're gone. Devansh, you're gone. Ojas, you're gone. The problem with this thing is, look at this thing. You're getting 11.25 means once you cross 10, the gravity has changed. You can't use the formula. Others, anyone else? Let me show you the first part. Yep, right, Vignajit. Look at the first part. You can't use the three equations directly. That is because the G is changing. So let's use them for each section. Don't use it for the whole thing. Use it for each section separately. So let the projection be U here. So when you reach here, let the speed be V1. So for the first section, the final speed will be V1 square minus U square is 2AS. This would be how much? V1 square minus 225 minus 2. G is, so A is minus 10 and S is 10. That is 25. So V1 is 5 meters per second. Now you can apply the formula for the first section because G is constant. Now look at this, what happened. The final velocity in the first section is the initial velocity in the second section. You're getting it? Now for the second section, now you need to check again, okay? We can check. What is Hmax? Hmax ka formula is Vy square by 2Ay. So here Vy is V1 square and what is Ay? G by 2. This you didn't do, Purvaja. You just took there also G only. I feel so.
Yes,
Now
sir.
this would be 25 by 10, that is 2.5 meters. This is less than 10 meters, right? So the particle does not go to the third section. The question got over. Particle doesn't enter third section. So it stopped in the second section only by traveling 2.5 meters. The gravity has changed. Therefore, Hmax would be, you traveled the entire first section, then you traveled 2.5 meters in the second section, then you stopped. Have a look at this. Are you getting this? You directly can't do. For example, listen everyone. Suppose agar yahan pe na, instead of 2.5, if I got 12, then what should I do? That means you enter the third section also. Means again you have to say here the velocity is v2, then again you have to check. Are you getting it? You have to keep checking for every section, are you crossing the boundary or not? If you're not crossing, you're safe. If you crossed, then you have to again go back. Please have a look at this. All got this? Now the main question, find the minimum speed so that it never comes back. So with what speed should I throw? This thing will never come back. This will just keep going forever. We'll go to infinity. Let's try that. Try, you got another 2 minutes. Any doubts on the first part, please ask me. The second part makes this question real and advanced worthy question. How did you get a minus sign, right? But that is right. If I just forget about the minus sign.
So it was just a typing error.
Okay. You have one answer. Think. Take a minute more. Try to figure it out. Let's see. Now again, the same problem we are facing. You cannot use the formula directly. We can use it only for each section. And we noticed the final velocity in the first section is the initial velocity for the second section, and so on. So the final velocity of one section will be the initial velocity for the second section. So if you start here with speed u, let the velocity be v1, let the velocity be v2, let the velocity be v3, and so on. So for the first section, the formula would be v1 square minus u square is 2, the gravity is minus g, and the height is 10. This is for the first section. For the second section, v2 will be the final and v1 will be the initial velocity, which is 2. The gravity is minus g by 2 and 10. This is for your second section. v3 square minus v2 square is 2 into minus g by 2 square into 10, g by 4. This is your third section. And if you keep on doing this, you will end up with vn square minus v n minus 1 square would be 2 into minus g by 2 to the power of n minus 1 into 10. Now, if you add all these things, you will see something interesting. v1 square will cancel, v2 square will cancel, this will cancel, this is cancel. You can't solve them individually, but when you add all of them, they all go off. You end up with vn square minus u square will be 2 g and 10 common with a minus sign, and you're left out with 1 plus 1 by 2 plus 1 by 2 square, so on till 1 by 2 to the power of n minus 1. These kind of functions, they have a name for it. They're called telescopic functions. Ever heard that word? There's a name. When you add function like this and they cancel it out, they call them telescopic functions. Now, when you add this up, you end up with, now you want to go to infinity. If it goes to infinity, that means n will tend to infinity. So your Vn becomes V infinity. So this becomes V infinity square is equal to U square minus 200. This guy would be 1 plus 1 by 2. Now suddenly the sequence becomes an infinite GP. So let me show it in the previous page. So we have V infinity square will be U square minus 200, 1 plus 1 by 2 by 1 by 2 square going till infinity. That's your GP. That would be 1 by 1 minus half. That's U square minus 400 is V infinity square. Since it goes to infinity, means it never stops. Because there's nothing called infinity. Infinity means you're never going to stop. You'll just keep going forever. You will never reach infinity. Since it goes to infinity, this implies it never stops. That means, therefore, V infinity is greater than equal to 0. You can be equal to 0 also, because when you reach infinity, you have 0, means you're never going to reach infinity anyway. So you end up with U must be greater than equal to 20 meters per second. Therefore, the minimum speed is 20 meters per second. If you throw with 20 meters per second, you're never going to come back. And did you observe something interesting? For 15 meters per second, you're reaching 12.5. If you just increase the speed by 5 meters per second, you'll go off. There, have a look at these functions. Any doubts, please ask me. Anyone not convinced with any particular step, not clear, please ask. That's the main idea there. You write the equation and the final velocity for one guy is the initial velocity for the next guy, and so on. Any doubts on this? Next page, any doubts here? Anyone not clear with anything particular?
Sir, how did you say that it was greater than equal to 0? Is that because it's square?
Because
Is it
नहीं
because
ऐसा नहीं. It is square का mathematically it is 1, but the other reason is this na. You said you should never come back, right?
yes, sir.
Means what should be your final velocity then?
It should be more than 0.
More than 0, right? Means you should never come back, na. Means you should never stop only.
Yes, sir.
So that means at infinity, your velocity should be greater than equal to 0. That is the thing.
Yes, sir.
All clear? Next one. A particle is projected with speed u. It is observed the distance traveled fifth second and sixth second is same. Find u and h max. How do we do this? Yeah, right, Rehan. Yeah, assume G is 10. Nothing is given, take G as 10. I told you that in the beginning only, right? Let's see. If T5 कैसा है record? See, did you guys use the SN का formula क्या? See, let me tell you one thing. Suppose when you project it up, let's say if this situation S5 is equal to S6 occurs while going up, think of like this. Let's say this is T is equal to 4, this is T is equal to 5, and this is T is equal to 6. So this distance would be the 5th second. This distance would be 6th second. Now you tell me, while going up, can they be equal? Who will be bigger, 5 or 6? 5, no? S5 will be greater than S6 because as we go up, speed decreases. As we go up, the speed decreases. So this situation cannot happen while going up. Suppose the second situation, if it has gone up and if it is coming down, let's say this is T is equal to 4 and this is T is equal to 5 and this is T is equal to 6. So this is S5 and this is S6. Now who will be bigger? S6 will be greater than S5 since it is coming down, the speed is increasing. Means you can't be equal if you're going up. You can't be equal if you're coming down. Then what is the only possibility you're left with? You should be going up and coming down at the same time. That means the only possibility left for you is T is equal to 4 is here. T is equal to 5 should be the topmost point, and you must be traveling equal times on both the sides. Means it must be symmetrical about the center, isn't it? Is that making sense? You can't travel while going up. You can't travel while coming down. This is the only thing left. All got this? Now, the problem with using that SN formula is, what is SN? SN is not distance, displacement. So we found out what we found out. So time of ascent is 5 seconds. And what is time of ascent? U by G. So you got 50 meters per second. Then what is H max? U square by 2G. That's 2500 by 20. 125 meters. Check it out. That is the idea there. But G would be opposite. G is always minus sine Surya. Whether you go up or whether you come down, gravity is always downward. And down is always negative. Isn't it? In the formula which you use, we always take G as negative. All clear? Surya, got that? Next one. Turning the page. Any doubts? Devansh, Arnav, Daksh, Arya, clear this. After explaining everything, you want to see the question now. God. Clear? Next thing. So we have a building here. We have a particle released from rest. And the building ka height is h. This particle is thrown up with speed u. This thing goes up and comes down. The building ka height is h. This particle is thrown down with speed u. The building ka height is h. Here the time of flight is t1. Here the time of flight is t2. Here the time of flight is t3. Find t1, t2, t3. Let's get this. Now we started throwing from buildings. Root h by 5. Okay. Leave your answer in terms of g. That's okay. Get the remaining two. First one is fine. First one is fine. Most of you got it. Second one. Let's see. Let me show in something similar for all of them. You'll realize. I don't want to mug up these results, but see how we are doing this. Listen carefully. For the first one, when you leave it from here to here when it is falling, what's the displacement? What is the displacement? Minus h. Be careful. It is not h. Direction matters. From here to here, when you're coming down, the arrow is pointing downward. The displacement is negative. Okay? For this guy, when you're starting here and you're reaching here, what is the displacement? Minus h. What is the displacement? Minus h. All three particles have same displacement. Whether you throw up, you throw down, I don't care. The sign is all negative for all of them because displacement is simply initial and final point. I don't care whether you're going up, you're going down, anything, displacement is this. I hope everyone is clear with this thing. Anything up is positive, anything down is negative. Keep this simple sign convention. I know in school you learned in the direction of gravity, positive, opposite, don't do all that shit. Keep it simple because you'll get confused. Now, what is the speed here? U is equal to 0. What is the acceleration? Minus g. There, that's your data there. So you want to find time. So s is equal to ut plus half at square. So minus h 0 minus half g t1 square. So therefore t1 is root 2h by g. The second one, the speed uy is plus u because it is going up. Ay is minus g because it is going down. So write the equation. S is equal to ut plus half at square. This is minus h. This is ut minus half gt square. We get a quadratic here. Half gt square minus ut minus h is equal to 0. This comes out to be time t2 is u plus root over u square plus 2gh by g. I'm not taking the negative root. Time can't be negative here. For the third one, again, uy is minus u. Ay is minus g. So here the time would be minus h is minus ut 3 minus half g t3 square. You find the roots for this, you end up with t3 will be minus u plus root over u square plus 2gh by g. So the only thing you should realize is the only data which is changing is these 3 points. Look at this. That one u ka value plus and minus and 0 messed up the whole thing. So whenever you solve these problems, don't try to mug it up. Just remember the displacement is minus h. The velocity will adjust the time. Have a look at the answers. That's it. You know displacement, you know velocity, you know acceleration. You need to find time. The only equation which fits is s is ut plus half at square. Clear? Let's see. Now the same thing. If you look at this here, there is a pretty nice result. If you take t2 into t3 and multiply, you will end up with u plus root over u square plus 2gh by g into minus u plus root over u square plus 2gh by g. You end up with minus u square plus 2gh by g square. That turns out to be 2h by g, which is nothing but t1 square. So do mug up the result, quite a standard one. So t1 square is t2 into t3. What is t1 here? This is the time when you release it from rest. So the time square when you release it from rest should be equal to the product of the other two times. And if you observe something, this is independent of speed. Huh? You throw with any speed, this formula is valid. You have to throw up and down with the same speed though. This is independent of u and h. No matter how tall the building, no matter what speed you throw, this condition will always be satisfied. Now, exam, you won't have time to derive this result. So do mug it up, standard result. Exam like BITS, mains, Manipal, Vellore, these kind of exam, direct question is this. All clear with this? So there, that's the last one for the day. So next class, when we catch up, we are going to do more things. We'll be throwing different things from building. We'll also do variation in gravity also, what will happen. So that next class will finish with the vertical motion. And then after that, we'll start with projectile. So next class, we'll do more variations of throwing from buildings. So we have done almost 23 problems. So do start solving. You can start doing all these problems from this thing. You can do it from booklet, or you're doing from your booklet. You can do all these cases when you're throwing from buildings. The test is only until Thursday, so make sure to give it, right? And after the test gets over, if you think there is any question wrong, any mistake, you just